Today, more and more of us are becoming motivated to reduce the impact that we have on the environment, and in 2014, Welsh households recycled 54% of their waste. At Swansea University, postgraduate research scientist Rhys Charles is out to prove that waste can be a valuable commodity. He's taking waste industrial components from his partners in WearTech and recycling platinum that can be used by his colleagues in Specific, who are developing functional coated glass and steel products that will enable walls and roofs to generate, store and release energy.
Basically, I look at ways of exploiting additional value within the context of circular economy from electronic waste. So in this case, I was approached a little while ago by a company that had some waste thermocouples from their process. They generate about 40,000 of these a year, and each one contains a little platinum filament. And we looked to get these recycled, but we couldn't because there wasn't sufficient value that was recoverable through traditional recycling processes. I thought about it and looked at industrial symbiosis as an option, and also instead of recovering the platinum, turning it directly into an added value compound, so in this case chloroplatinic acid. So to buy a gram of that costs roughly about twice as much as a gram of platinum. So by doing that, you can immediately double the value available from the material. So we took these thermocouples and we digested them in acid and recovered the platinum as chloroplatinic acid with the intention of using it in Specific to replace the chloroplatinic acid they're buying from primary sources for use in the production of dye-sensitized solar cells. The significance is this: at the moment, in Europe especially, we are consuming far more resources than the Earth can sustain. The point of this project is to prove that waste is actually a valuable resource. We need to capitalize on this resource we're sat on, the waste. If we can use that to generate value, generate jobs, and secure a future for our planet simultaneously, it seems righteous. That's what we should be doing. Well, like all things, you just have to get cracking.
Take the thermocouple, break the glass and isolate platinum wires until you have enough to work with. Put the filaments in a beaker with aqua regia and boil until the platinum is dissolved. Allow the solution to cool and filter. Evaporate to dryness. Dissolve a small amount of recovered product and analyse with atomic absorption spectroscopy. Next, head to the laboratories at Specific. Score conductive glass and break into pieces. Apply titania paste to the glass photoanode. Cure in the oven at 550 degrees. Dye the titanium layer on the glass. Drill a hole in the counter electrodes. Apply a layer of chloroplatinic acid solution to the counter electrodes and reduce in the oven. Sandwich a thermoplastic gasket between the electrodes and seal in a t-shirt press. Fill cells with electrolyte, seal them and apply silver paint as a contact on each electrode. Attach cells to a solar simulator and measure photovoltaic performance.
So the real question is the chloroplatinic acid that we're able to isolate of sufficient quality and fit for purpose in dye cells in comparison to what you would buy from primary sources? And that's what we need to investigate next. As a proof of principle of industrial symbiosis and how it could work, this is great. It'll draw headlines because we're using waste that is going to landfill to produce green energy technologies. You know, I don't think this work I've done is the best work in the world, right? And I don't think it's necessarily going to change the world, but what I want to do is promote that way of thinking. And if some of the better minds than mine were to apply themselves to that way of thinking, we might really start getting somewhere fast. So my next trick will be to find something that is economically viable, that somebody can start looking at it, you know, scaling up straight away, which will probably be something related to the direct production of added value gold products from circuit boards and contacts and stuff like that, other components from electronic waste. An ideal world is one where people are not worried about where their next meal is going to come from. Are they going to get paid? Have they got a roof? Is their family safe? That sort of thing. But it would be a world where the future was a little bit brighter than maybe it is now. And a little bit like Star Trek, I guess.